So here we know that we have got the equation 4 and equation 5 with the two unknown values, that is x and y. So and both are same, so we can directly equate to the two equations and we can get one unknown value from this two equations. So here what we are doing, the equation 4 is multiplying with 5 and equation 5 is multiplying with 1. So equation 4 when multiplied with 5 you will get that minus 5x minus 85z is equals to 0, and equation 5 when multiplied with 1 you will get 5x minus 6z is equals to 3. So here 5x will get cancelled and 9 minus 91 z is equals to 3, then z value will become 3 by 91 amps. Okay, so it might be in the negative, so negative sign represents the current is flowing from D to B. Okay, so here what actually we have as we don't know the actual direction of the current which is flowing in the network, so we assume that the current is flowing from B to D. But after solving the equations, after solving these problems, we have analyzed that the current actually is flowing from D to B. So the problem here, we will solve this one more problem. So as of now, what we have saw is applying the KVL problem. Okay. Now we are going to see the solve the network. So we have to analyze the network and we have to resolve the network in a shorter way. Okay. So find the resistance between the terminals of the battery in bridge network as shown in the figure. So they are asking us to solve the resistance between this point and this point. So we have to find out the overall resistance value. So for this, we have start to delta transformation formula. So we have to apply that so that we can get here. Because here when we see this network, it is not that much easy to solve the network only with applying parallel and series logic. So due to the resistance R3, we cannot solve it by a simple series and parallel analysis. However, we can observe that R1, R2, R3 are in delta. Yes. So R1, R2, R3 are in delta. We can observe it. So we can convert this. We can transform this delta into this star. Okay. So now first considering. So now we are selecting this part, that is ABC part, which is in delta. Now we will convert it into star. Okay. So assuming that we are converting in this manner, star. So we are finding out of this value first. So this value, that is, let's say it is RA here. So the value of RA is equals to adjacent product of adjacents of two sides divided by all the resistance in delta. Okay. So that is RAB into RAC divided by RAB plus RAC plus RBC. Okay. So RAB into RAC, that is 12 into 18 divided by 12 plus 18 plus 6. Okay. So you are going to get that RA value as 6 ohms. In the similar way, we have to find out RB and also RC. So now RB will be equal to 12 into 6 divided by 12 plus 18 plus 6, which is equals to 72 divided by 36, which is equals to 2 ohms. And RC, which is equals to 18 into 6, that is 18 ohms into 6 ohms divided by 12 plus 18 plus 6, which is equals to 108 divided by 36, which is equals to 3 ohms. So now we got uh, we have removed the delta components, delta elements, and we have added it with the star elements. So that is nothing but we have converted the delta into the into star. Okay. So this is how it will look. So at node A, at node B and C, we observe now the delta part is eliminated and it has been replaced with a star. So now if we observe at this part and this part, okay, as there is no another connection here, only RB is connected to R4 and RC is connected to R5. So hence these two are in series. Okay. Likewise, RC and R5 are also in series. Okay. Now we are substituting the values. Okay. 6, 2, 3, 12, and 18. Now we can apply simple series and parallel technique to find out the resistance as seen by the battery. Okay, these at these two parts. This is series, RB and R4 are series, and RC R5 are series. Okay, so like this it will look. So now 18 plus 2 is 20, and 12 plus 3 is 15. So 2 and 18 are in series, and 3 and 16 are in series. It is 12, not 16. Okay, 12 are in series. So this part is going to become 20, and this part is going to become 50. Okay, now it will look like this. As a single resistor, we have to replace with a single resistor. Okay, now it is observed that 20 ohms and 15 ohms are in parallel. Okay, so we have to perform a parallel operation here, that is 6, this part. Okay, 20 into 15 divided by 20 plus 15. Okay, so after completion of this, so these two parallel resistors have done with the parallel operation, then we will get a single resistor like this. Okay, now this will become 6 and this will become 8.57. Okay, so that is what the parallel of in this parallel circuit we got 8.57. Okay, and we know that we can now we, after resolving this to a one resistor, single resistor, we can directly tell that the 6 ohms is in parallel with 8.57, I mean series with 8.57. So we can add it. Okay, 6 plus 8.57. So after taking the series operation, we will get the final resistance across the battery, that is 14.57. Okay, so this is how we have to solve a network which might be a very critical networks. Uh, for that, after applying the star to delta and delta to star transformation, we can easily resolve and we can easily find out what is an exact resistance has been involved in that network. So here another problem, three resistors, 1 ohm, 2 ohm, sorry, 1 ohm, 1 ohm and 2 ohms are connected in delta. Find the equivalent star. It is a simple network has been given. So this is a star network, I mean delta network. Okay, this is 1 ohm, 1 ohm and 2 ohms. Same. So we have to find star. So here this is A point, B point, C point, or A B C or A B C. In any way you can consider. So we know that to find out the resistance, to find out this resistance, the product of two adjacent resistance divided by the total resistance which are involved in delta connection. Okay, so here 1 into 1 divided by 1 plus 1 plus 2. That is RAB into RAC divided by RAB plus RBC plus RAC. Okay, so here we are getting 1 divided by 4, which is equals to 0.25. Okay, so now this value is equals to 0.25. At the same way, similarly, the next others. Okay, so 2 into 1. So here, so finding out RB, this will become 1 into 2 divided by 1 plus 1 plus 2. So 1 plus 1 plus 2 is equals to 4. So 1 into 2 is equals to 2. So 2 by 4 is equals to 1 by 2, which is equals to 0.5. Okay. So RC is also the same way. 2 into 1 divided by 4. So 2 divided by 4 is equals to 1 by 2, which is equals to zero point 0.5 ohms. So in the star, RA is 0.25, RB is zero point 0.5, RC is zero point 0.5. Okay. So this is a very simple network, direct transformation from delta to star. So likewise, you have to convert a star to delta or delta to star. And yes, it is. We have to analyze that a very critical network also can be solved by using parallel series, delta and star. All this combination, we can solve a network. And yes, dear students, you have to practice so many problems so that you will get a grip on a problems that let the problem may be any type, you could be able to solve it. Okay, so here uh, while talking about problems, always practice is needed. Okay, now you could able to solve the Kirchhoff laws network and also star delta. So we will see here. Kirchhoff laws are used for, it is only DC. No, they have said AC to DC. Sorry. Okay. So we have seen the Kirchhoff laws problems and also the star delta transformation problems. Hope you have understood the two problems on the two topics which we have considered for today. Okay. Thank you so much.